Hello everyone, welcome to the session on Apache Spark with Databricks. Hi, I am Jayant Kumar Mulmudi and I have more than 17 years of experience in consulting, research and academics. My clientele includes MNCs and have worked at Google INC California. Apart from this, I have worked on various technologies including SDLC, cloud technologies, machine learning, deep learning, analytics, big data, and various other data projects. I've also conducted more than 1,000 sessions in offline and in the online mode. So before we start with our lesson, let us understand the objectives of this lesson. So in this lesson, we will be learning about Apache Spark, architecture of Apache Spark, how to construct an RDD using Apache Spark, and also run Apache Spark on Databricks Community Edition. One of the prerequisites of this lesson is to have Python knowledge and also be able to understand what is distributed computing. And you need to have access to the internet from a web browser. So let us begin with what is Apache Spark. So Apache Spark is a data processing engine or an execution engine that can be used for data engineering, data science, or machine learning. And it is provided in various programming languages. The programming languages are Python, Scala, Java, SQL, and R. It can run on a single node or it can run on a cluster. So Spark can be executed on a single machine. It is also called as a single node, or it can be run on a group of machines, which is called as a cluster. So Spark was started in the year 2009 as a research project at University of California, Berkeley. And it was started by Matei Zaharia to overcome the shortcomings of iterative MapReduce and data engines. And this is what helped in to also open source in the year 2010. And as the developer community increased, it was added to Apache Software Foundation in the year 2013. So Spark comes up with what is called as a Spark core in its architecture, and it has 4 different programming languages: Java, Scala, Python, and R. And on top of these, we have what is called as the Spark Data Frame API, which can be used to represent the underlying data in a tabular format. And there are other components that are also exposed on top of Spark Core and Spark Data Frame API, they being Spark SQL, Spark Streaming, Spark Graphics, and Spark Machine Learning. Spark SQL is used to run SQL queries on top of Spark. Spark Streaming is used for real-time applications or streaming applications. Spark Graphics is used for graph algorithms. And Spark Machine Learning is used to run machine learning algorithms on Spark. Spark can be run in a standalone mode, or it can be run in a yarn, or it can be run in Mesos, or it can be run in Kubernetes. All of these, yarn, Mesos, and Kubernetes, are resource managers or cluster managers. So when we say a cluster is nothing but arrangements of machines in a master-slave architecture. So we'll have a master node that takes the incoming requests or a program that is submitted to the master node, and then they are executed on different machines called as the worker nodes. So this is how it would look like a Spark cluster mode. We would have what is called as the Spark context object on the master node. This Spark context object interacts with the cluster manager in order to get the details of the cluster. And the place in which, or the main function in which the Spark context is run is called as a driver program. And when the program is submitted to the cluster manager, they are submitted to the worker nodes. So the worker nodes are the areas at which the program actually runs, and it runs in dedicated resources provided in the worker nodes called as executors. So they run on these worker nodes and they are getting executed in the executors, which are nothing but the computational resources provided on those machines. And all of this is coordinated by the cluster manager. The cluster manager could be Hadoop Yarn, or it could be Mesos, or it could be Kubernetes. So what made this difference between the original MapReduce programming paradigm and Spark? We discussed that there were some shortcomings earlier. So let's try to understand what these shortcomings are. So when we have MapReduce, which is also called as Hadoop MapReduce, the data is read from a disk, and then it is iterated or read and written back to the disk. So there is a continuous iteration during MapReduce. And this causes slowness in the execution of the program. And this is where Spark optimizes it or reduces that shortcoming. So when the data is read from the disk, Spark tries to iterate it or load it to RAM, which is nothing but a distributed memory. So data is there in the memory for the computation. So iterative computations are done only to the RAM without writing it to the disk, making this kind of programming paradigm or programming computational style much faster than what is happening in MapReduce. And that is where Spark became one of the most famous programming computations in a distributed environment. So when we look at Spark in-memory computation, this is how it would look like. The data is read from a disk, loaded into RAM, which is nothing but a distributed memory, and there are operations that could be performed. A transformation will give us, again, some kind of an object, and an action will write the data back to the disk, or a result or a value is generated. So the basic building blocks of Spark in which the data is processed or computed is basically called as resilient distributed data set. And the short form for resilient distributed data set is RDD. The primary characteristics of RDD are it is computed in memory, the data is partitioned, it is evaluated lazily, the data is immutable when it comes to RDD, it is resilient or fault tolerant, and it is coarse-grained. We'll look at these characteristics as we get along. So with respect to the operations on RDD that we had seen earlier, discussed briefly, there are two types of operations that can be performed on an RDD. The first one is a transformation. The transformation, when applied on an RDD, gives us an RDD back. And an action, when applied on an RDD, which is essentially partitioned data, this action, when applied on the partitioned data, will either give us a result or a value or write the data back to the disk. So these are the two types of operations that are available on RDD. These are transformation and actions. And as we move ahead, we will look at various transformations and various actions that could be performed as operations on a given RDD. Once again, RDD is nothing but a basic data abstraction in Apache Spark. We could see that as a data structure in Apache Spark. So when it comes to parallel computation, we could see the data could be read from two different sources. Let's say the data is read as input 1 as one source and input 2 from another source. This could be two different files or two different data sources altogether. This could be a file like a XML, and this could be a CSV, or this could be a database, and this could be a normal file. So input 1 can be any data source, and input 2 can be any other different data source. So data is parallelized, and then an RDD is formed. On this RDD, transformations can be applied to get back a transformed RDD. And from there, this could be joined or transformations could be applied, and then an action could be generated to get the final output or the result. So let's begin by creating an account in the Databricks website, and let me navigate to the URL that is available here. So we will use this URL docs.databricks.com/getting-started/community-edition.html.